Hey guys, this is Rick. About a year ago, in February of 2018, I did a series of presentations on the status of the Lightning Network. So, seeing how back then people were saying it's 18 months out, 12 of those months have passed as of now, so I thought it prudent to take a look at where we are today. So, the Lightning Network 2019 Update Edition. Last year, I outlined 8 problems with the Lightning Network. That's supposed to be Bitcoin BTC's savior and way forward and whatnot. 4 of these problems are major, that you must be online to receive funds, that routing is completely unsolved, there's a legal liability for Lightning Network nodes, and that it has a reactive security model. And 4 additional problems with the onboarding, that there's no cold storage, it's not production ready, and the complexity of it all. And let's see what has happened with these 8 problems 1 year after I mentioned them. Let's take them one at a time. Now, remember that last time I did this presentation, Lightning Network was supposed to be 18 months out. 12 of those months have now passed. So if 2/3 of the time have passed, then reasonably these problems should be almost solved, entirely solved, or there should at the very least be a very good idea of how to attack them. So, first problem. Somebody must be online to receive money. First problem. This has, yeah, I don't want to call this solved. A solution has been presented that is not even a workaround. The so-called solution to this problem, that somebody must be online to receive money, is that somebody else must be online to receive money. In hiring so-called watchtowers to do the being online part for you, this is supposedly solved. But this is not a solution to the problem that somebody needs to be online in the first place. This is not an improvement over Bitcoin, which requires absolutely nobody to be online in order for a transaction to go through. So a big fat red cross on the problem 1 as far as solutions go. Problem 2, routing is still unsolved. And much of the discussion has happened in the field of routing in this problem. And when you're discussing, you're realizing that there is a remarkable synchronization of the arguments coming from supposedly different people, which tells you that there's some sort of synchronization of these talking points going on behind the scenes. All of which are wrong, by the way, except one. And since this is the largest field of discussion, I'll come back to this after covering the other 7 problems that I outlined in 2018. So, problem 3. There's a legal liability for nodes in Lightning Network that route money. Because, as I said a year ago, once you deposit money into a channel with someone, you are triggering the whole custodial funds framework in the code of law. You literally become a bank. And if you're acting as a bank without a banking license, then the authorities knock on your door with a wheelbarrow with 1 ton of bricks that they're going to dump all over you. It's very unpleasant experience, I hear. And you know, when I presented this in 2018, the reactions were No, this is just FUD. This is false. This is fear, uncertainty, and doubt. There is no truth to this whatsoever. This guy is just trying to scare you off. Interestingly, a year later, when you're bringing up the issue that, you know, if you're transferring money, if you're literally transmitting money, then you're going to need a money transmitter license. And when you're bringing this up a year later, people are saying, well, yeah, probably. By the way, look at the nice weather. And change the subject, just turn on a dime and talk about something else. This is particularly relevant in terms of the so-called solution to so-called routing we'll be coming back to. Sorry, I'm laughing. I know where I'm going with this. You'll see. Anyway, problem 4, reactive security. A year ago, I was talking about how IRC has reactive security model, and they're still struggling with channel takeovers and net splits and whatnot, and it's just a morass of pain and a place you don't want to go to. And you know, IRC is just a chat system. There's no money involved here. This is just about being the king of the hill with the magic internet points in the magic channel. If you're involving real money, this is going to become a lot more intense. And you know, this reactive security model, the Lightning Network community just doubled down on it with this watchtower so-called solution that, yes, you must have somebody online so they can react to a threat and neutralize it so you don't lose funds. This is wrong at the conceptual level. You don't build a reactive security model. If you don't react quickly enough, you're going to lose your money. That's the wrong way to build it. There's no other way to say this. Problem 5, onboarding. You're seeing stories right now about actual people trying this, and it's tech-savvy people, and they're just coming back fuming and saying, what is this stuff? This is so far from where it needs to be in order to actually be an improvement to lots of people that it's ridiculous. And you know, in order to onboard somebody to a new service, it needs to be an order of magnitude better than what they have today. And you know, there's no custodial Lightning solution to talk of except the Twitter tipping bot. And besides, you don't want to go custodial in the first place. And so you need to run your own node, and you need to be online all the time. And you can get this Casa node where you're plugging it into itself for it to work. And I'm not even making that up. This is... I haven't seen any progress on this in the past 12 months. Let's just end it at that. Problem 6. There's no cold storage. Of course there isn't, because you need to be online all the time. This, again, comes from the reactive security model, that you can't store funds safely. The very design of the system means that you are unable to store funds safely. And I mean, this is a design flaw. I don't know what to add there, as in you can't fix this without radically changing the design from the ground up. Problem 7, it's not production ready. The Lightning Network is not production ready. And the next sequence, if you knew nothing about the Lightning Network, except what I'm going to show you now, that is going to tell you all that you need to know. In 2015, actually, December, but I'm writing 2016 here for the benefit of the doubt. In early 2016 or late 2015, it was announced as 6 months away, or even literally less than 6 months away. In 2017, it was 18 months away. In 2018, it was still 18 months away. You would expect it to be 6 months away here if it was 18 months away the year before, but no, it's still 18 months away. And now in 2019, it is several years out. Normally, the time to completion in any project decreases over time. The time to completion in this project increases over time. If you knew nothing else about the Lightning project, this tells you all you need to know. It is never going to be production ready. It is a dead end for all intents and purposes. Which brings me to the last problem, complexity. Simplicity wins. When you're starting to add complexity to solve the complexity you've already added, like watchtowers, you're adding a band-aid at best, and you're not really solving the key problem. With that said, let's return to routing. Problem 2. This is where most of the discussion has been, and I want to address some talking points here very specifically. Routing, we'll remember, means that our channel down here needs to find a way up there to reach the intended payment destination. It does so by finding a path through all of these nodes, illustrated here as, well, I guess they show up as dots. They're short cylinders here, or databases, but all of these nodes, where these are highly connected in between each other, then there's slightly less connected, and then there's us out here who are using mobile or whatever. Routing. The word routing has a very specific meaning in network engineering. It means hop by hop path discovery. You don't discover the entire path to the end system before you start sending the package that's supposed to go to that end system. You send it just one hop of the way, and then you're dependent on that system sending it one step closer and one step closer again, and so on until it reaches a destination. That is what routing means. Every single hop makes a routing decision of where to send the package next. There's a lot of nonsense, techno-babble going on in this field. The first of which is, yes, of course there's routing in Lightning. It's source routing. Source routing very specifically means not hop-by-hop path discovery. So they invented this term, powdered moisturizer, and are pretending it makes any kind of sense. This source routing means that the origin system is responsible for calculating the entire path to the payment target. That is not what routing means. It's that simple. This is not routing. This is path discovery. This is path calculation. It is not routing, end of story. The next term you'll hear thrown around a lot is onion routing. This is a little closer to what routing means, but it's still not routing in the path discovery sense of the word. Onion routing means source obfuscation, that you're deliberately obfuscating, dressing in smoke and mirrors, the origin of this package. The term onion routing comes from the Tor network that has onion routing in its name, the O and R. And this is not in any way, shape, or form a path discovery mechanism. This is an obfuscation mechanism, which can absolutely have its uses. But it is not about path discovery. So, with this said, there are 4 talking points that are quite common right now as to why this routing problem in Lightning isn't a problem at all. The first is path discovery is a trivial problem. The idea of finding a path through a known map like this has been solved decades back, and you'll hear the names of algorithms being thrown around like A-star pathfinding or the Dijkstra algorithm. I think that's a Dutch name, so it's probably pronounced Dijkstra. Doesn't matter, you'll still see it spelt like that. And yes, these are about path discovery. But let's take a step back here. If we're calculating a path through this known map, we are assuming something. We are assuming that we know what the map looks like. We don't know what this map looks like. We need to not just discover the path, we need to discover what these entire how these entire set of nodes are connected to each other and how the channels go. We don't know what even the map looks like. And worse, once we have some information about what the map looks like, it's already out of date. Because transactions will have happened in the meantime that change the liquidity in these channels, and so we might not be able to route a payment where we would have been able to route it at the time the information was produced for us about that part of the map. The existing path discovery mechanisms assume that the map is known. They assume that the map is known. The bigger problem here isn't just path discovery, it is map discovery. And it's important here to realize that the internet has not solved this problem. This is not solved on the internet that has had 4 decades of the brightest network engineer minds of the planet to solve this problem, and it has not been solved. On the internet, the hop-by-hop routing happens in a trusted backbone. Trusted, using something called BGP, the Border Gateway Protocol. And the BGP does not handle adversaries. If you're announcing, say, which actually happened in Russia, that, hey, from now on, I should handle all the packets going to the Visa and MasterCard networks, then all over the world, the internet will start sending you packets intended for the Visa and MasterCard networks. And obviously, any financial network must handle adversarial conditions. It must handle dishonest participants because there's frankly going to be a metric ton of them. Next talking point. It doesn't matter that the small device, your phone, or this little clicker here needs to find the entire path to the end destination because you have a GPS in your car and your GPS can find a path to the destination anywhere in the world. So this can't possibly be any different, can it? And this is dishonest because you're playing on this idea that a small device and a small device are conceptually the same because they're about the same size, aren't they? And so routing through a network is not very different from routing in the streets, and a GPS can take you to any spot on the planet. Well, it is different. And finding a path through this means that you're finding your way through an unknown map, and there's no up, down, left, or right here. It's just numbers. It's all just random numbers. A GPS, if we're going from here, from Berlin to Potsdam, just outside of Berlin, then a GPS can conclude that a two-step hop, first southwest and then slightly west-northwest, or mostly west, then south or west-southwest, and then southeast will take you to the destination. When you're routing on the internet, there's nothing like this. You can't sort of add vectors together and see if they match your intended destination. If you are going from this address to this address, then there is no such thing as using logic and see that, okay, we're going to go left, left, right, right, up, down, and then we're pressing BA start and we're at our destination. It doesn't work that way. It doesn't work that way. A route between these two addresses will typically look like a 15 to 20 long sequence of what's just random numbers. An internet unit and a GPS unit have fundamentally different challenges when it comes to routing, and implying that they're the same, yeah, they're not. They're absolutely not. This is a non-answer. Next talking point about routing. Liquidity doesn't change. You see this also in the discussions from lots of different people. Liquidity doesn't change. I talked about this, that when we're sending something through this network, there's each of these links is like an abacus. You're setting up the link and you have 50% liquidity on one side, 50% on the other. And the liquidity can flow in both directions. You can set it up with all the liquidity on one side or the other as well, but the typical case would be 50% in each direction. And when you've exhausted the liquidity on one side, you can't flow anymore from that. So you need to set up a new channel. That means that a payment going from here to there means that it needs to move one ball, assuming we're moving one ball of money, on this channel, 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 and so on. So we're assuming that there is a ball to be moved. We're assuming that there is liquidity in the channel. But, as I said last year, every successful transaction changes the global routing table just a little bit. Just a little bit, because it moves these balls on the abacus strings, and therefore there's less liquidity available in some channels after one transaction, more in some others, in particular in the other direction. And since it changes the global routing table, the challenge is exponentially harder than the internet, and even the internet doesn't have this problem solved. And when I'm pointing out that every transaction changes the global routing table just a little bit, the talking point is, no, it doesn't. I'm sorry, but this isn't an argument. Yes, it is. It really changes the global routing table. No, it doesn't, not at all. And then somebody says you could compare to an ATM and the ATM network. You know, if an ATM runs out of money, you just go to the next one. It's not a problem. And I'm not sure where they're going with that, because they just said that in this transaction, the liquidity does change just a little bit. An ATM can run out of money. Even if every ATM withdrawal just is a little bit, it still changes the ATM's balance. Every transaction here will change the liquidity balance in the channel. And even a tiniest change will reset the global routing. So the argument against this basically uses this logic. When I'm pointing out that it changes the liquidity a little bit, the response is no, it doesn't change at all, because it just changes a little bit, so it doesn't change at all. If that makes sense to you, let me know. And the last talking point. This has popped up fairly recently. It's you're seeing a lot of people talk about this, and that's yeah, routing, nah, it's not really interesting, you know. It doesn't matter at this scale. It doesn't matter at this scale. You're seeing people like Andreas Antonopoulos and others talk in this way. And there's sort of a point to it that it's kind of working right now. It's currently a bunch of hobby connections among friendly enthusiasts. But you know, this stuff aims to become a global standard, full of adversaries, full of dishonest participants. Saying that it doesn't matter because it works at this scale, it's not an interesting problem, let's just solve that when we get to it. That's a little bit like saying that, you know, we are going to create weekend vacations on Alpha Centauri. How's that? Wouldn't that be cool? Yeah, you know, it would be cool, but there are some challenges with it. How are you going to create faster than light travel? You know, light takes 4 years to get to Alpha Centauri one way. So if you're planning to spend a weekend there, how do you plan to solve the travel part? Don't worry about that. We've tried this out. We've been going back and forth to Kansas right now, and it works great. This is literally how that comes across. Like, you should at least have an idea of how you're going to solve the very real challenges around the corner. And there is one such idea when it comes to routing. There is actually a fully credible, workable solution. And that's the observation that these center nodes in the center of the cloud are probably going to be quite tightly connected. They're probably going to have this routing all sorted out in between them. So I'm hearing people say that, you know, no, the end user won't have to care about routing. People will just name their well-connected hub and their channel to it. So people will talk that I'm connected to this guy, you're connected to this guy. That's how we solve the payment. People will name their well-connected hub and the channel to it. This well-connected hub, as we remember, needing a banking license from earlier in the discussion. But, you know, if you're creating this whole new payment system where for payments to work, you need to give somebody a bank and an account number, then what's the whole point?